All right, this lesson we are going to talk about what we do with negative and zero exponents. Let's begin. First, when we see something like this, we want to split everything up. Split them up so that we have like base over like base. So, 18 over 18, x to the 20th over x to the 20th. Now, anytime we divide a number by itself, that always equals 1. So 18 divided by 18 equals 1. Right? So those will cancel. Everything equals 1. Here you might notice we have x to the 20th over x to the 20th. That is a number divided by itself. So you know any number by itself equals 1. But this is going to help us out a little bit with two things. When we divide like bases, our x's are like bases, we subtract our exponents. We know that from last lesson. 20 minus 20 gives us 0. Well, anything to the 0 power equals 1. So this whole entire expression all equals 1 because everything cancels out. So let's do the same thing here. We are going to split this up so that we have like base over like base, and we're only going to do one at a time. So w to the 8th divided by w to the 8th, when I divide like bases, I subtract my exponents, which gives me w to the 0. Again, anything to the 0 power equals 1. So far we have 1 times whatever our z's reduce to. When we divide like bases, subtract our exponents. That gives me just z to the 7th, and 1 times z to the 7th just equals z to the 7th power. There's your answer. All right, let's do this again. Except this time now we have 3. So we have our coefficients, we have our x's, and we have our y's. We're going to split everything up. First, I'm going to split my coefficients, then my like base of x, and then my like base of y's. So 9 divided by 3, that gives me 3. There we go. When I divide like bases, I subtract my exponents. 5 minus 2 gives me 3, so that's x to the 3rd or x cubed. When I divide like bases, I subtract my exponents. 12 minus 12 is 0. Anything to the 0 power is 1. So these essentially will cancel for us because we have 3x to the 3rd as our final answer. Here again, split it up. I have 5 to the 1st power, x to the 0 power. 5 to the 1st power just equals 5. X to the 0, anything to the 0 equals 1. So this really equals 5 times 1, which is just 5. Here, these parentheses tell me this whole thing is to the 0 power. It does not matter if the number is negative or positive. Anything to the 0 power is 1. All right, now we know when we divide like bases, because we have like bases here, we subtract our exponents. The numerator, exponent in the numerator, minus the exponent in the denominator, gives me 2 to the negative 3rd power. Now we're dealing with these negative exponents. We don't like negative exponents. We want positive exponents. Whenever we have a negative exponent, we simply flip it. This happens to be over 1, so I'm going to flip this entire thing. So I get 1 over 2, and then when we flip it, our exponent becomes positive. So if it's in the numerator, like it is in this case, 2 to the negative 3rd, when that goes to the denominator, it becomes a 2 to the positive 3. And then 2 to the positive 3rd power is 8, so this would equal 1/8. Down here, like we've been doing, split everything up. Coefficient over coefficient. Like base over like base. 100 divided by 200 gives me 1/2. Now here, there's a couple ways we can do this. Because we have a fraction here, 1/2, right? We can stick with subtracting our exponents. Exponent in the numerator minus the exponent in the denominator gives me b to the negative 25th. Whenever I have a negative exponent, to make it positive, I would take the reciprocal of that, which gives me 1 over a positive b to the 25th. Since b to the 25th is in the denominator, then, and my 2 is in the denominator, I am left with 1 over 2 times b to the 25th. The other way to look at it, we can see I've got 50 b's in the numerator and I've got 75 b's in the denominator. Here's where you ask yourself, do I have more in the numerator or do I have more in the denominator? 75 is bigger, so that means I have more than the denominator. So I know my b's are going to be in the denominator and all my b's cancel in my numerator. And then ask yourself, how many more are down there? Well, 75 is 25 more than 50. We're going to be doing more of those. Here we go. Split everything up. A to the negative third over a to the fifth. Like base. Here's my b for my like base. And here is my c for my like base. Now, when I have like bases, when I divide like bases, I subtract my exponents. So it's negative 3 minus 5, which gives me a to the negative 8th. Whenever I have a negative exponent, to make it positive, I take the reciprocal, which means to flip it. If it's not a fraction, it's always over 1. So to flip that, it would be 1 over a to the 8th. So here I see that a to the 8th is in the denominator. Divide like bases, subtract my exponents. 7 minus 2 gives me b to the 5th. Another way to look at this right here, are there more b's on top or on bottom? There are more on top. Ask yourself how many more. Well, if there's 7 on top, 2 on bottom, that means 5 more are on top. So that means b to the 5th stays on top. I know a to the 8th is in my denominator. B to the 5th then is in my numerator. Divide like bases, subtract my exponents. Anything to the 0 power equals 1. Therefore, I am just left with b to the 5th in the numerator over a to the 8th in the denominator. So, power to a power. Here we go. I'm going to rewrite this and give everything an exponent. 2 to the 1st, x to the 3rd, y to the negative 5th, all to the negative 2nd. When I have a power to a power, I distribute and multiply exponents by other exponents only. So I have 2 to the negative 2, x to the negative 6th, because 3 times negative 2 is negative 6, and I have y to the positive 10, because negative 5 times negative 2 is a positive 10. So let's deal with the first number here, 2 to the negative 2. I have a negative exponent. In order to make it positive, I have to take the reciprocal. It is not currently a fraction, so I put it over 1. I flip that, I get 1 over 2 squared, or 2 to the positive 2, which equals 1 over 4. So I now know that for my final answer, 4 is going to be in my denominator, because 4 is in the denominator right here. Then I look at my x to the negative 6th. It's not currently a fraction, so let's make it over 1. And I take the reciprocal to make that x positive. So I flip, and I'm left with 1 over x to the 6th, where x to the 6th is in the denominator. So down here with my 4, I put x to the 6th. Now I look at this last, y to the 10th. That's a positive exponent. There's nothing to reduce here. There's nothing we can do to reduce this. It's not currently a fraction, so if I were to make it a fraction, I put it over 1, which tells me the y is in the numerator. So I go to my final answer. I put y in the numerator to the 10th. And this would be my final answer. again, I'm going to break up my like bases and do it one by one. Here's where I'll put my final answer. So, when we divide like bases, we subtract our exponents. 2 minus 5 is a negative 3. The exponent in the numerator minus the exponent in the denominator. This is not currently a fraction, so I'll put it over 1. In order to make the exponent positive, I do the reciprocal. 1 over m to the third. I see that m is in the denominator, so for my final answer, I put m to the third in the denominator. The other way you can do that is you can look at this, ask yourself, whoops, are there more m's in top in the numerator, or are there more m's in the denominator? You should see that there are 5 in the denominator, so there's more in the denominator. Ask yourself then, how many more? Well, there's 3 more, so m to the third goes in the denominator. We can do that right away with our n's here. Are there more n's on top or on bottom? I see there's more on top. How many more? There's 1 more. So you should know that our answer is going to be n to the first for when we reduce this. But let's go ahead. When we divide like bases, we subtract our exponents. 4 minus 3 is 1. I don't need to write the 1. You can if you want. So our final answer is n over m to the third. Last, is this number positive or negative? Well, I see the negative exponent. It is not currently a fraction, so I'm going to put it over 1. In order to make a negative exponent positive, we have to take the reciprocal or flip it. Okay. Now, when I flip a number, the number stays negative, but the exponent stays positive. It's the exponent that switches, not the number itself, just the exponent. Now, here's where we have to have a strong foundation in math. So negative 3 squared versus, or the quantity negative 3 squared versus negative 3 squared. This means negative 3 times negative 3, which is a positive 9. What we have down here means negative 1 times 3 squared, which is negative 1 times 3 times 3, negative 1 times 9, which equals negative 9. That's what this means. So this really means negative 1/9. So this number is actually going to be negative, and this work helps explain why this is negative.